Hello everyone, my name is Ryan Lee, and today I'll be going over the Physics 2212 lab charge tape, the second part of it. So the purpose of this lab is to compare the differences in data when assuming the piece of charge tape is a point charge versus when it's not. So in the second part, the charge tape, it assumes that the charges are evenly distributed across the surface of the tape. And this lab uses a different, more sophisticated code to make a more accurate representation of what actually happens in the charge tape lab. So for the results, for my second charge during the lab, I got 3.9850870 times 10 to the negative 8 coulombs. And the original charge from the first part of the lab was 1.217 times 10 to the negative 8 coulombs. This charge is less than a third of the second charge that I got. And for the electric force, I got 0.00202086 newtons, and the force of gravity, I got the same thing but negative. So here are some of the assumptions that I had to make during this lab. Air resistance was assumed to be negligible and had no effect on any of the results. And another assumption is that no other external factors besides gravity and electric force come into play during this lab. And charge on the charge tape is also assumed to be evenly distributed across the piece of tape. So here are some of the fundamental concepts for the second part of the charge tape lab. It's pretty much the same. Coulomb's law, force equals Coulomb's constant times charge 1 times charge 2 over r squared. Force equals mass times acceleration, Newton's second law. Coulomb's constant, which equals K equals 8.988 times 10 to the 9th Newton meters squared over Coulomb squared. So here's the experimental model for the lab, for the charge tape lab. You just have two platforms holding up a piece of tape, and then you bring another piece of tape near the first one, and then it should repel the piece of tape. And for the distance, for D, I got 0.026 meters. So here's the code that I used. So the top part of this code, that draws in the vectors for the 3D model. And this part, it prints out whatever the value for the charge, gravity, and electric force is. This second part over here, this does the calculations to calculate charge. And it'll display it because print charge is C plus Q. So here's the actual graphic for the code. As you can see, here's the arrows from the electric field. And it says that my charge is 3.985087 times 10 to the negative 8 coulombs. So here are some possible sources of error. So instrumental error, the ruler could have been inaccurate. This isn't that likely, but it could have happened. Experimental error, accidentally reading off the wrong number on a ruler. Moving anything holding the system around, like the tables or the platform, or even handling the piece of tape too many times. Because if you do that, then the charges will move around the tape and not in a way that'll make them charged. And air resistance was also neglected here, and it could have had an effect on the final result. So here are the questions. So what if you had modeled each of your tapes as a single point charge like in the previous lab? So for this revised charge, I got 3.985 times 10 to the negative 8. Original is 1.217 times 10 to the negative 8. The charge here is more than 3 times larger, and it's larger here because the charge is distributed across the entire piece of tape and not just in the center. The charges that are closer will have an exponentially larger effect than the ones near the center. So that's why it's so much bigger on the revised part. So why do these estimates differ? Which value is more closer to the real value? These estimates differ because the point charge only assumes one singular charge at the center of the charge tape, and the second model distributes the charges evenly so that there are some that are closer but some that are further. The second, more sophisticated model reflects the nature of the charge tape more accurately, since in real life, the charge tape doesn't just have one singular charge in the center. So thank you for listening. Goodbye.